Okay, dear students, good morning. Already we started the inverse trigonometric functions and we solved one exercise 2.1 and properties also 6 properties are solved. Now we are going to solve these 7, 8, 9 and 10 properties. Okay, now try to observe it well. You see, all these properties are important. These three properties are asked in the 2.2 exercise also. Okay, na? Moreover, these are all important properties. You put the star notation also. You put it star notation. Okay, na? It is very important properties. You see, in order to solve the 7th property, we are asked 3 sin inverse x is equal to sin inverse of 3x minus 4x cube. In the regular formulas, in the first chapter, first and second chapter, we have this formula. Sin 3 alpha is equal to 3 sin alpha minus 4 sin cube alpha. Sin inverse x, let it be alpha. Then 3 alpha, sin 3 alpha is 3 sin alpha minus 4 sin cube alpha. Okay, na? Just to remember, to make it by heart, this is the method. You see, let you assume this is alpha. Then this is 3 alpha. It is the sin inverse comes to this side, it is sin 3 alpha. Okay, na? Sin 3 alpha is 3 sin alpha minus 4 sin cube alpha. Okay, na? Here also same. 2 alpha, you assume. It is cos 2 alpha is 2 cos square alpha minus 1. Yeah, formula is there. 3 alpha in this case. Cos inverse comes to this side. Cos 3 alpha is 4. Cos inverse comes to this side. Cos 3 alpha is 4 cos square alpha minus 3 cos alpha. Formula is there. Here also same. 2 alpha you assume. Tan inverse comes to this side. Tan 2 alpha is nothing but 2 tan alpha by 1 minus tan square alpha. Sin 2 alpha. 2 tan alpha by 1 plus tan square alpha. In the compound angle, that formula is there. Again, cos inverse comes to this side. Cos 2 alpha. Cos 2 alpha is 1 minus tan square alpha by 1 plus tan square alpha. Very easy. If you take it as easy, if you assume it is easy, then it is easy. If you assume it is very difficult, what these are all, these domains and the intervals are very confusing, means you leave out this part. It is a secondary thing. First you remember this one. It is very easy. You think that it is easy, then it is easy. If you see in a difficult way, it is very difficult. Okay, now? Right. Now I am going to solve the 7th property. Please observe me. Let sin inverse x is equal to alpha. Always you assume alpha. Then that implies sin alpha. Sin alpha is equal to x. Sin alpha is equal to x. Yeah, okay, na? Right. Sin alpha is equal to x. Now, we will consider sin 3 alpha. You may get some doubt. Sir, what is the need to consider sin 3 alpha, sir? I consider sin 2 alpha or sin 4 alpha. That is wrong. Only sin 3 alpha. Why? Because the problem is like that. You are assuming this is alpha, na? Here. 3 alpha is there. Sin inverse. The question is like that. Sin inverse come to this side. Sin 3 alpha is. So sin 3 alpha I have to consider. Sin 3 alpha is 3 sin alpha minus 4 sin cube alpha. Sin 3 alpha is 3 sin alpha minus 4 sine cube alpha. This is a formula. If you have a doubt in this formula, that means you are not in a position to by heart this one. You have to by heart. It is the previous chapter. Sine 3 alpha is 3 sine alpha minus 4 sine cube alpha. Now I come to this side. You say sine 3 alpha is 3 sine alpha. Sine alpha means x. So this is 3x minus 4x cube. 4x cube. Okay now? So 3 alpha is equal to sine comes to this side. Sine inverse. If the sine comes to this side, is sine inverse 3x minus 4x cube. What is alpha in our assumption? It is 3 sine inverse x is equal to sine inverse 3x minus 4x cube. Okay now? Yes, it is proved. But some addition is also there. You see, we have to prove this one also. It is also needed. Okay now? It is okay. With one condition is there, it is also to be added. We have to solve that one also. How? You see, we are considering sine 3 alpha. Sine of any angle, whatever it may be, sine is always lying in between minus 1 and plus 1. Okay? Sine goes to on all sides. 3 sides are there on all sides. We apply sine inverse. It is sine inverse of minus 1 less than or equal to sine inverse of sine 3 alpha less than or equal to sine inverse 1. It is minus pi by 2 less than or equal to. It cancels 3 alpha less than or equal to. It is pi by 2. Okay na? Minus 1 in the case of sine is minus pi by 2. 1 is plus pi by 2. You send 3 on both sides. Pi by 6 less than or equal to alpha less than or equal to pi by 6. Will agree? Okay na? We are dividing with 3 on all sides. Pi by 2 by 2, pi by 6. Here also pi by 2 by 3, pi by 6. Okay na? Again you apply sine. It is sine of minus pi by 6 less than or equal to sine alpha less than or equal to sine pi by 6. Sine minus pi by 6 is minus sine pi by 6. It is minus 1 by 2 less than or equal to sine alpha is nothing but x is there. It is less than or equal to sine pi by 6 is 1 by 2. Okay na? Don't confuse. 1 or 2 times you repeat this video and see and each and every moment. Okay na? Otherwise it is very difficult. It seems to be very difficult. Don't feel that it is difficult. If you go through it 1 or 2 times, 3 times, let it be. Then it is easy. Otherwise it seems to be difficult. Okay now? This addition property, this addition proof also is added in the total property. Okay na? Yeah. So it is solved. Now, okay, is it clear? Yeah. Now, I want to solve the 7th problem. You see, 7th is over, sorry, 8th problem. 8th problem. It is in the cos. 2 cos inverse x is equal to cos inverse of 2x square minus 1. With this condition. First we leave it out this one. First we take that one. Let cos inverse x is equal to alpha. Okay now? Here it is in the 8th property is alpha. You leave it out that 7th formula. That implies x is equal to cos alpha. Okay now? X is equal to cos alpha from this assumption. And we want to consider cos 2 alpha. Why? Because here, what is the lesson to consider cos 2 alpha means? You see in the problem, we are assuming this is alpha, 2 alpha. Cos inverse goes to there, it is a cos 2 alpha. So we have to consider cos 2 alpha. What is cos 2 alpha? In the second chapter, compound angles and multiple, sum multiple. Cos 2 alpha is 2 cos square alpha minus 1. 1 minus 2 sin square alpha is also there. Cos square alpha minus sin square alpha also there. That is the first. Second, let cos inverse x is equal to alpha. Okay, now here it is in the eighth property is alpha. You leave out that sum formula. That implies x is equal to cos alpha. Okay, now x is equal to cos alpha from this assumption. And we want to consider cos 2 alpha. Why? Because here, what is the lesson to consider cos 2 alpha means? You see in the problem, we are assuming this is alpha, 2 alpha. Cos inverse goes to there, it is a cos 2 alpha. So we have to consider cos 2 alpha. What is cos 2 alpha? In the second chapter, compound angles and multiple, sum multiple. Cos 2 alpha is 2 cos square alpha minus 1. 1 minus 2 sin square alpha is also there. Cos square alpha minus sin square alpha also there. That is the first. Second, third, fourth one also is there. 1 minus tan square alpha by 1 plus tan square. But here we need this one only because it is in the terms cos. Now it is 2x square because is cos alpha is x square minus 1. It is cos 2 alpha. So 2 alpha is equal to cos inverse. This cos inverse comes. Cos comes to the here, it is cos inverse. What is alpha? Is substitute here. Alpha is 2. Alpha means it is cos inverse x. Okay, now is cos inverse 2x square minus 1. Yeah, it is a product. But yet is something. I have to prove this one also. Don't forget. You see, again, what we consider cos 2 alpha, we consider. Cos is always in between minus 1 and 1. Cos any angle. Cos something is always lying in between minus 1 and plus 1. Taking cos inverse on all sides. It is cos inverse of minus 1 less than or equal to cos inverse of cos 2 alpha less than or equal to cos inverse 1. Okay, now cos inverse of minus 1 is pi less than or equal to, it cancels to 2 alpha less than or equal to cos inverse 1 is 0. Okay, now? Okay, now pi less than or equal to 0. Here we get in a different way. A twist is there. The cos is, it is about to cos. The cos is a decreasing function. It is a decreasing function. You see, the horizon, it is pi by 2. Sine is increasing. The sine curve is like this. It is a sine x curve. Whereas cos 0 is 1 and cos pi by 2 is 0. This is cos curve. Okay, na? Okay, na? Cos 0 is 1. Cos 60 is 1 by 2. Say it is 60. It is 45. 1 by 2. Okay, na? Cos 60 is 1 by 2. This is 30. So it is decreasing. Cos 90 is 0. Okay, na? So it is decreasing the curve. So we write in some order. Say it is 0 less than or equal to 2 alpha less than or equal to pi, like that you write it. And dividing with 2, 0 by 2 is 0 less than or equal to alpha less than or equal to pi by 2. Will agree? Okay, na? We are dividing with the 2. Right. Again we apply cos in order to get this one. Cos alpha. It is cos 0 less than or equal to cos alpha less than or equal to cos pi by 2. Okay, now I am writing here. Cos 0 is 1. Cos alpha is x. And cos pi by 2 0. It is also related with cos. So you write in the one order. It is 0 less than x less than 1. Okay, na? It is okay, na? Like this. You have to learn it. There may be some difficulty, some twist is there. Why suddenly we interchange? Due to this is a decreasing function. Sin x is increasing function, cos x is a decreasing function. Okay, na? Yeah. So here the 8th one is also solved. Now, okay, is it clear? Now, 9th one. Let cos inverse x is equal to alpha. You may feel that always you are taking alpha, sir. Here alpha is cos inverse x. In the previous problem, 8th one, alpha is to cos inverse x. Of course, there also. In the 7th one, alpha is sin inverse x. Don't confuse. The problem is over. Okay, leave it out. Freshly I am writing 9th one. Let cos inverse x is equal to alpha. Then cos alpha is equal to x. X? Okay. Yeah. Now I want to consider cos 3 alpha. You may get doubt. What is the necessary, sir, to take cos 3 alpha? Means here the problem itself is done. This is 3 alpha and the cos goes to that side is cos 3 alpha. So we have to consider this one. Cos 3 alpha is 4 cos cube alpha minus 3 cos alpha. Like that. It is multiple compound angles. The formula is there. Cos 3 alpha is 4 cos cube alpha minus 3 cos alpha. That is 4 cos alpha is x. Cos cube is 4x cube minus 3x. Okay, now it is cos 3 alpha. Now 3 alpha is equal to this cos comes to this side. Cos inverse of 4x cube minus 3x. What is alpha? Alpha is cos inverse x. So 3 cos inverse x is equal to cos inverse of 4x cube minus 3x. It's okay now. It is a proof. Here also we have to prove this interval also. You see now. Now you are getting the idea. We are taking cos 3 alpha. Whatever it may be. It is always lying in between minus 1 and plus 1. Yeah. Yes, okay. And cos inverse. Cos inverse of minus 1 less than or equal to cos inverse of cos 3 alpha less than or equal to cos inverse 1. We are applying cos inverse. What is the necessary in order to get 3 alpha? Here it is 3 alpha. Very simple. Cos inverse, cos inverse, cos inverse, cos cancels. Cos inverse of minus 1 is pi. Cos 180 is equal to minus 1. Here 1 is cos pi by 2. Cos 0. So we get here 0. Same in the previous one also. We write it as 0 less than or equal to 3 alpha less than or equal to pi. For your sake I am writing. Or otherwise directly we may say. Okay. Why? Because I interchange it is pi is less than 0 here. Now you change it. 0 is less than pi. Now dividing with 3 on both sides, on all sides. 0 by 3 is 0 less than or equal to alpha less than or equal to pi by 3. Yeah. Okay now? Yeah. Now you see, apply on all sides cos. Cos 0 less than or equal to cos alpha less than or equal to cos pi by 3. it is 1 less than or equal to x, cos alpha is equal to x is less than or equal to cos pi by 3, cos 60 is equal to 1 by 2. Here also you change it because it is related with the cos. The cos is decreasing. 1 is less than 1 by 2. This is wrong. So 1 by 2 less than or equal to x less than or equal to 1. Okay na? So it is also proved. Okay na? Go through it well. 1 or 2 times, 3 times also. Slowly you will learn it. Okay na? Yeah. So this is solved. Now 9 is over. Next. Just pass. Yeah. 10th problem. 10th property. You say it is related with the tan inverse x. This is very important. LHS is same 2 tan inverse x in terms of tan inverse 2x by 1 minus x square. In terms of sin inverse x 2x by 1 plus x square. In terms of cos inverse x 1 minus x square by 1 plus x square. Okay na? It's a fantastic concept. Please try to understand and take it account. You see the tan inverse x. This is very important. LHS is same 2 tan inverse x in terms of tan inverse 2x by 1 minus x square. In terms of sin inverse x 2x by 1 plus x square. In terms of cos inverse x 1 minus x square by 1 plus x square. Okay na? It's a fantastic concept. Please try to understand and take it account. You see, let tan inverse x is equal to alpha. That implies tan alpha is equal to x. Okay na? Tan alpha is equal to x. You know it. Now we consider tan 2 alpha. That's what I am telling. What is the necessary to take to consider tan 2 alpha? In the problem itself, it is 2 alpha. Tan inverse goes to that side, it is a tan 2 alpha. It is a tan 2 alpha. So that is why I am considering a tan 2 alpha. Okay now, right here. Tan 2 alpha. It is 2 tan alpha by 1 minus tan square alpha. A formula is there. Okay now? Yeah. It is 2x by 1 minus x square. Tan alpha is x. It is tan 2 alpha. So 2 alpha is tan goes to this side. It is tan inverse 2x by 1 minus x square. Will agree? What is alpha? Alpha is tan inverse x. Okay, tan inverse x. Alpha is tan inverse 2x by 1 minus x square. Okay, is it clear? Yeah, it is proved. But you see, related with this one, again, it is also included in the property. I am writing in the board, the masters are writing on the board addition to this one. But while we are solving this problem in the exams or test, you connect here only. Continuity must be there. Here the problem is there, the board is very small. That is why we are writing the side by side. Okay, right. Again, tan alpha we are considering. Tan alpha is lying in between minus infinity and infinity. Will you agree? Tan alpha is in between minus infinity plus infinity. What it may be the value? 50, 160, 200, 1 lakh, whatever it may be, it gives the value. If the alpha is increasing, the values are increasing. If alpha is decreasing values, it is going to reach minus infinity. You see, tan alpha is in between minus infinity plus infinity. Don't write less than or equal to, less than or equal to, because infinities are not a number. It's boundless, it is open. Now, tan inverse of minus infinity less than alpha less than tan inverse infinity. That means it is minus pi by 2 less than alpha less than plus pi by 2. Agree? Yeah. Again I am applying tan to get that one. Tan alpha. You see, not just, I'm sorry. We have to consider the 2 alpha. Yeah. Not that one. Tan 2 alpha, tan 2 alpha, you take it. It is 2 alpha. Yeah. 2 alpha. 2 alpha, don't confuse. We are considering tan 2 alpha, not tan alpha. So tan 2 alpha is lying in between minus infinity plus infinity. Not alpha, not 2 alpha, or whatever it may be that. Okay, now. Tan inverse of minus infinity, it is tan inverse of plus infinity. Is it plus pi by 2, it is minus pi by 2. No, don't confuse. It is a 2 alpha. Okay, now? Yeah. You divide with 2 on all sides. It is pi by 4 less than alpha less than plus pi by 4. Okay, now? Yeah. Again, we apply tan on all sides. It is tan of minus pi by 4 less than tan alpha less than tan pi by 4. It is minus 1. Tan of minus pi by 4 is minus tan by 4. Minus 1 less than tan alpha is x less than tan pi by 4 is plus 1. Okay, na? Okay, na? So here the first part is yeah. Don't confuse that. Minus infinity less than tan 2 alpha. What we consider, we have to take it. Okay, na? This is one thing. Now, same. Objection is the same. Don't confuse that. Minus infinity less than tan 2 alpha. What we consider, we have to take it. Okay, na? This is one thing. Now, same. Objection is the same. I am going to solve that second one. Assumption is same. We consider, you see, sine 2 alpha. Don't get the confusion. Why? Because here this is 2 alpha. Sine inverse go to that side. Sine 2 alpha. So I am considering sine 2 alpha. Sine 2 alpha is 2 sine alpha cos alpha first formula. But another formula is 2 tan alpha by 1 plus tan square alpha is also is there. So it is 2x by 1 plus x square. Okay, na? Therefore 2 alpha is equal to sine inverse 2x by 1 plus x square. Will you agree? Yeah. Okay, na? That sine comes to this side, sine inverse. What is 2 alpha means tan inverse x. 2 tan inverse x is equal to sine inverse of 2x by 1 plus x square. Okay, Nana? It's proved here. But we have to prove this interval also. You see, again, what we consider sine 2 alpha. Sine 2 alpha is lying in between minus 1 1. There is the previous one, tan 2 alpha. It is lying in between minus infinity plus infinity. But here minus 1 plus 1. Okay, na? The range of sine is very small, minus 1 to plus 1. Okay, na? Yeah. But less than or equal to is there, because minus 1 1 are numbers, whereas infinity are not numbers. So sine inverse of minus 1. Many times I told you it is sine inverse of minus 1 is minus 0.2. Less than or equal to 2 alpha. Already we solved. It is 2 alpha. Okay, na? 2 alpha. Sine inverse of 1 is pi by 2. Okay, na? Dividing with 2 minus pi by 4 less than or equal to alpha less than or equal to plus pi by 4. Okay, na? Is it clear? Yeah. Again, I am applying all sides. Three sides are there. Tan. It is tan pi by 4 less than or equal to tan alpha less than or equal to tan pi by 4. It is minus 1 less than or equal to x. Tan alpha is x less than or equal to 1. Okay now? For the previous one is minus 1 less than x less than 1. Why? Because minus infinity plus infinity will come. It is open whereas this is closed. This is the difference. Okay na? Is it clear? Third one. The same assumption is as it is, but the consideration is a different one. You say, consider cos 2 alpha. Why? Because here 2 alpha, cos inverse goes to that side is cos 2 alpha is equal to 1 minus tan square alpha by 1 plus tan square alpha. Many formulas are there. Every time I am giving the formulas. You see that cos 2 alpha is first cos square alpha minus sin square alpha, or 1 minus 2 sin square alpha, or 2 cos square alpha minus 1, or 1 minus tan square alpha by 1 plus tan square alpha. Yeah, okay now? The fourth one I am writing because it is related with the tan. So it is 1 minus x square by 1 plus x square is there. This is cos 2 alpha. So 2 alpha is cos inverse 1 minus x square by 1 plus x square. What is alpha? You substitute there. It is 2 tan inverse x is equal to cos inverse of 1 minus x square by 1 plus x square. Yeah, it is a proof. But as usual, again we have the this part is there. Again, what we consider cos 2 alpha consider. It is also in between minus 1 and 1. You take on all sides cos inverse. Cos inverse of minus 1, it is cos inverse of cos is 2 alpha. Cos inverse, it is pi less than or equal to 2 alpha less than or equal to, it is 0. Cos inverse 1 is 0. Okay na? So you write it as 0 less than 2 alpha less than or equal to pi. What is the reason? Already I told you. Cos, this is related with the cos. Cos is a decreasing function. Pi is not less than 0. 0 is less than pi. At that time you write it. You have to change it. There is no any mistake. Again you divide with 2. It is 0 less than or equal to alpha less than or equal to pi by 2. Okay na? Again apply cos. It is cos 0 less than or equal to cos tan 0, it is tan alpha less than or equal to tan pi. We get 0, tan alpha is nothing but x less than or equal to tan pi by 2 is infinity. Okay na? So x is more than 0. Less than infinity is meaningless. It is just you write whatever it may be, it is more than 0. So we write it as x is greater than 0. Okay na? Greater than or equal to also 0. So that is also mentioned. It is proved. Okay na? Totally it is the proof. 10 properties. Very, very important. Try to understand it well and make it many number of times you repeat and repeat it. Then only it is not possible. In a live class, okay then. I will come to you and we can clearly on the paper we will discuss. But now the position is not permitted to us. Please try to understand. Number of times you repeat. If any problem, any doubt is there, you know my number, my cell number. You call me at any time. I will receive that call and I will give clarification. Please try to understand it. Yeah. Okay. Pass. Yeah. Next, 11th property. Sine inverse x plus or minus. First we take plus. Sine inverse y is sine inverse of x root 1 minus y square plus y root 1 minus x square. Okay, na? Yeah, sir. You see, say it is alpha and it is beta. Alpha plus beta. Sine inverse come to this side. Sine of alpha plus beta. Sine alpha cos beta plus cos alpha sine beta. Okay, na? If it is plus or minus, here also plus or minus. Whereas cos inverse x plus cos inverse y is there. It is cos inverse of xy minus root 1 minus x square root 1 minus y square. Okay, now here also is saying it is alpha and it is beta. Alpha, beta. That is cos inverse comes to this side. Cos of alpha plus beta is cos alpha. Minus, that means cos of alpha plus beta is cos alpha cos beta minus sin alpha sin beta is there. Plus is there, it is minus. If minus is there, it is a plus. Okay, now. Now, I want to solve this property. Let sin inverse x is equal to alpha. And sin inverse y is equal to beta. That is sin alpha is equal to x and sin beta is equal to y. If sin alpha is equal to x, what about the cos alpha? Root of 1 minus sin square alpha. It is root of 1 minus x square. Similarly, cos beta is root of 1 minus sin square beta. Root of 1 minus y square. Okay, na? Is it clear? Now, I want to consider it is sine of alpha plus beta. Every time you may get some doubt. What is the necessary, sir, to take sine of alpha plus beta means here the problem sine of alpha plus. If it is alpha plus beta, sine inverse comes to this side. Sine cos inverse x is equal to alpha. That implies cos alpha is equal to x. Therefore, what about sine alpha? Here just change. Cos inverse x is equal to cos alpha is equal to x. Then sin alpha is, you know it, 1 minus x square with root. You know it, similarly. Similarly, cos inverse y is equal to beta. We are taking this one, for this one. So, cos beta is equal to y now. Therefore, sin beta is equal to root of 1 minus cos square beta. It is y square. It is simple. Now here also we consider cos of alpha plus beta. What is the necessary? At every time you try to understand it. Alpha plus beta. Cos inverse goes to that side is cos of alpha plus beta. Cos of alpha plus beta I am considering is cos alpha cos beta minus sin alpha sin beta. Don't forget this formula. The trigonometry formulas are very important. Not only the trigonometry, these trigonometry formulas are everywhere. Even in the second year, I mean, we are in second year, second PU, in the calculus part, it's very, very important. The Ramesh sir is giving that concept differentiability, continuity, and next calculus part is the integrations. There it is very essential, all these formulas, not inverse, these formulas, very important. Okay, leave it out. Cos of alpha plus beta is cos alpha cos beta minus, it is sin alpha sin beta. Okay, now, what is cos alpha? Cos alpha is equal to x, cos beta is y, minus sin alpha is root 1 minus x square. Here is there. Sin beta is root 1 minus y square is there. Okay, now. So alpha plus beta is equal to, this is cos inverse of xy minus root 1 minus x square root 1 minus y square. Okay, na? Okay, na? Is it clear? But what is alpha? It is cos inverse x. What is beta? Cos inverse y. It is cos inverse of xy minus root 1 minus x square and root 1 minus y square. Okay, is it clear? I think that here only I will tell. If you consider minus, it is a plus. Here only, not here. Okay, now. By seeing this video or classes, but maybe by simply you are observing and you are seeing, it will not come to your mind. You have to write on your paper by using just you take that question and you try it. You try to solve it with your own effort. Some doubts will come. That must be come to your mind. If doubt is coming there, you observe once again this one. Like that we have to practice. The math is like that only. Try to understand it. Here also the condition is the minus 1 less than or equal to x less than or equal to plus 1. At last you write this one. It is okay, no? It is not need that to write because this is given in the definition itself only. And that way. Okay, no? Yeah. Pass. Yeah. It is last property, very important. Tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy. For x greater than 0, y greater than 0 and xy less than 1. It is pi plus tan inverse x plus y by 1 minus xy. It is x greater than 0, y greater than 0 and xy greater than 1. Okay, now? And it is simply pi by 2. For x greater than 0, y greater than 0, but xy is equal to 1. Okay, now? It is an important one, no doubt. But the proofs are not given in our syllabus, but it is needed in the extra syllabus. I mean, in the supplementary, these are given. So we have to learn, but not now. By hearting, this formula is needed. You see, first I will tell it. You see, here in all cases, x, y are positives. X greater than 0, y greater than 0. In all cases, in the 3 cases. Whereas the product xy less than 1, that is direct. If xy product is greater than 1, it is pi added. Why what is the necessary means we will discuss again, not now. And xy is equal to 1. It is simply pi by 2. Okay now. Say, I will tell you. Suppose through an example I want to tell you how to apply. This is very typical property. Suppose tan inverse 1 by 2 plus tan inverse 1 by 3 is there. So xy, what is xy? 1 by 2, this is x. 1 by 3 is 1 by 6 is less than 1. So first property, we are in first property. That too x is equal to 1 by 2 is greater than 0. X is equal to 1 by 3. Why? It is also greater than 0. So the first property is applicable here. Now it is simply tan inverse of 1 by 2 plus 1 by 3 by 1 minus 1 by 2 into 1 by 3. That is tan inverse of 3 plus 2 na LCM by 6. Here also 6 minus 1 by 6. Cancels 5 by 5 is the tan inverse. 5 by 5 is 1, so its answer is 5 by 4. Yeah. Like that we have to apply the property. Either this one or second or third. It is based on this condition. First I have how to apply and tell. Suppose the problem is like this. It's tan inverse 2 plus tan inverse 3. You see, x is equal to 2 in this case is greater than 0. Y is equal to 3 na greater than 0. xy is equal to 2 into 3 na is 6 means greater than 1. So second property. So at this time it is pi plus tan inverse. It is 2 plus 3 by 1 minus 2 into 3. Okay na? So it is pi plus is tan inverse 5 by 1 minus 6 is minus 5. 5 plus tan inverse of minus 1. It is pi minus tan inverse of minus 1 is minus pi by 4. So it is 3 pi by 4. Okay. It's a different one. Why I am telling this example means where we have to apply these different types of properties. Yes, okay. If xy is greater than 1, we apply pi plus this one. If xy is less than 1, here we apply the first property like this. Okay now? Here only I want to tell. What is it clear? You see. Suppose one more example. Tan inverse 2 by 3. Okay na? Plus tan inverse 3 by 2 is there. Here x is equal to 2 by 3 is greater than y, y is equal to 3 by 2 greater than 1, xy is 2 by 3 into 3 by 2 is getting cancelled, 1 will come. So it is the third property. So it is, you see, here also directly not pi by 2. How it comes, I will tell you. Tan inverse by using the first one. It is 2 by 3 plus 3 by 2 by 1 minus 2 by 3 and 3 by 2 cancels. We get tan inverse. It is 4 plus 9, 13 by 6. LCM 4 plus 9, 13 by 6. By 1 minus 1, 1 cancels and 1 minus 1 will get it is 0. If anything by 0 is infinity. Infinity means tan pi by 2. So at last we get pi by 2. Yeah, will agree? Tan inverse of infinity means tan inverse tan pi by 2. Tan pi by 2. Tan inverse tan cancels pi by 2 will come. So like that we have to apply. xy is less than 1 property, greater than 1 another property, xy is less than 1 property, greater than 1 another property, if it is equal to 1 more property, and again a fourth property is also there. If it are this property, you may confuse. Okay, now I want to explain that property. Okay, now leave it out. Proof. Let tan inverse x is equal to alpha. That implies tan alpha is equal to x. Tan inverse y is equal to beta. That implies tan beta is equal to y. Okay, na? These are the results. Yeah, okay. It is tan alpha, it is tan beta. Now I am considering tan of alpha plus beta. At every time you may get some doubt. What is the necessary to consider this one means it is including the problem itself, in the property itself, in the cosine itself. You say this is alpha plus beta. What we are prove in RHS? Tan inverse. That tan goes to this side, tan of alpha plus beta. That is we have to consider. So it is tan alpha plus tan beta by 1 minus tan alpha tan beta. This is formula in the component. Tan alpha is x and it is y by 1 minus the x y. Okay, now what is alpha plus beta? This is tan of alpha plus beta. Now you see, therefore alpha plus beta, alpha plus beta is tan comes to this side, tan inverse of x plus y by 1 minus xy. Okay, now what is alpha? Tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. Okay, now this is simply without the conditions. Okay, now I will give again this kind of the last video of this chapter only. Ending of this chapter, I will tell. Some another properties are also there that is important for the objective for JEE Mains or IIT. Separately, I will give a class for that one. Okay, now that is an extra one. There we will do it. Okay, now is it okay? So all properties are completed. Now we go to exercise 2.2. Okay, now? Yeah, okay.